First thing we want to notice in this question is that it says solve, not prove. So we want to solve this one. So that means we don't have to draw the line. And when looking at this question, right now we can't solve it because we have two different trig functions. So is there a way I could change one so that it could be only in sine or only in cos? Change the sine squared. We can't change the cos because it's not squared. And when using those formulas, we've talked about it before, sine squared plus cos squared equals 1. That doesn't mean that sine plus cos equals 1. So the only thing we can substitute out is this sine squared. So I'm going to rewrite everything else. But instead of sine squared, what am I going to write? 1 minus cos squared. If I distribute things and combine my like terms, you might notice we have a quadratic equation here. So we're going to either need to factor or use our quadratic formula. Can you see when I distribute that, I'm going to get a positive 2 cos squared x. I still have a minus 3 cos x. And this minus 2 combined with that plus 3 will give me a plus 1. As far as factoring this, remember that equals 0. Only option for 2 cos squared, 2 cos x and cos x. Only option for 1, 1 and 1. Is there a way that I can use my outside and my inside to get a minus 3? Outside is 2, inside is 1. If they're both negative, negative 2 minus 1 will give me negative 3. Do a quick check. Does everything else still match up? Negative 1 times negative 1 is 1. 2 cos times cos is 2 cos squared. Perfect. So if we split this here, we have cos x equals a half. Cos x equals 1. Is this on our pie plate? Yes, what family? Pi over 3 family. What quadrants? Quadrant 1 and quadrant 4. Is cos x ever equal to 1? Yes. Yes. Where? At 0 and 2 pi. So again, notice what we did. We solved it normally between 0 and 2 pi. I'm going to move these answers down. They don't like them on that black part. Okay. The last thing we do is we go check our domain. Was it between 0 and 2 pi? No. It was between 0 and 3 pi over 2, and 3 pi over 2 wasn't included, and 0 is. So when we go back to our answers, can you see that you can't have 2 pi? That's too far. We are just looking from here to here, from 0 to 3 pi over 2. Are there any other answers I have to cancel out? 5 pi over 3 is in part because that one was in quadrant 4. Ooh, that was fancy. I went like this. Fun. Okay. Not quite as fun as coloring with crayons, but close. So those are our only 2 answers as a result. But you're going to get into that habit of solving between 0 and 2 pi and then having to check your domain afterwards. Okay, the one for practice. Number 10. It's because it's really happy because we're done this question.